Hello, good evening sa lahat ng grade 10 na nandiyan dyan at nanonood ngayon ng live session ko. So, at this point, I am going to discuss to you about the polynomials. Okay, so hanapin ko muna yung application window. Eto. Oh my gosh. Mali. Okay, so let's start with this one. Ouch. Okay, so at this point, we are going to discuss about what is a polynomial function. So I hope meron sa inyo na mag-comment below kung ano yung mga dapat nyong malaman o mga gusto nyong malaman about sa polynomial function. Okay? So, let's have a discussion first. What is a polynomial? Polynomial is made up of two terms, namely poly, meaning many, and nominal, meaning terms. A polynomial is defined as an expression which is composed of variables, constants, and exponents that are combined using mathematical operations such as addition, subtraction, multiplication, and division. And based on the numbers of terms present in the expression, it is classified as monomial, binomial, and trinomial. And examples of constants, variables, and exponents are as follows. So these are the constants. It is written as 1, 2, 3, and so on. So those are counting numbers. And also, it can be negative also. For the variables, it is represented by letters. And also for the exponent, it is represented by the superscript, or the numbers that are smaller written at the upper right portion of the variable or of the constant. So at this point, this example, 5 here is the exponent. Okay, so we have here an example of a polynomial. 5 is the coefficient, and this 2 is the exponent. X is referred as the variable, and also your y is referred as the variable, and 2 is your coefficient. And since 7 here is only a number, therefore it is referred as constant. Your plus sign and minus sign is referred as the operator of your polynomial. And this one, 5x squared, is considered as one term, 2y is considered as another term, and 7 is considered also as another term. Okay, its notation is represented by p of x equals the polynomial. Sorry. If the variable is denoted by a, then we can also write p of a. For example, p of a equals a squared plus 3a minus 5. Let's continue. Let's identify now the degree of the polynomial. The degree of a polynomial is defined as the highest degree of a monomial within a polynomial. So, it is the highest degree. Thus, a polynomial equation having one variable which has the largest exponent is called a degree of the polynomial. So, if we have a constant or zero polynomial, then the degree is 0. For example, we have 6. It is a constant. Therefore, its degree is 0. For a linear polynomial, the degree is 1. Take note that you are not writing the exponent 1 here, but you already understood that x has an exponent here. So that's 3x plus 1. For the quadratic polynomial, the degree is 2, and so the highest exponent is 2. As you can see, we have here 4x squared plus 1x plus 1. For the cubic polynomial, the degree will be 3. Take note of this, that the degree or the exponent, the highest exponent on this example is 3. And we also have the quartic polynomial, which has the degree of 4. So 4 here is the highest exponent. For example, if we have x raised to 6 plus 6, since the highest exponent here is 6, therefore we can say that the degree of this polynomial is 6. Again, when we are finding the degree of the polynomial, we have to look for the highest exponent. That will automatically be the degree of the polynomial. For the types of polynomials according to number of terms, we can have monomials, binomials, trinomials, and also polynomials. Okay, monomials, from the word mono, it means one term. Okay, so this one is one term, 6. 4x cubed is one term, and negative 5a squared b cubed is another one term. So these are monomials. And what's the difference of this when we have to compare it with binomials? Binomials have two terms from the word bi. So as you can see, the terms are separated by the operators. It may either be have plus sign or minus sign. Okay, so this 6x is one term and 2 or the constant is another term because they are separated by plus sign. That's why we call them binomials. Next is trinomials. For trinomials, we have 1, 2, 3. Three number of terms which is separated by our operators. So these are the examples of trinomials as you can see there. And also for polynomials, they have word poly, which means many. So it has many terms. When it is more than 3, that will be called polynomials. Some may have other special names for that, just like for 4 terms, we have quadrinomial. For 5 terms, we have quint, I think it's quintonomial, but then, okay, they are called polynomials in general. So they have many terms. We have 4 terms here, we have 5 terms here, and we have also 4 terms there. Okay, so here are the properties that you have to consider or you have to understand in polynomials. First property is the division algorithm. Is a polynomial p of x is divided by a polynomial g of x, it results to the quotient with the remainder r of x. Okay, other people or other books show this as d of x. It means that d of x is your divisor. Your P of X is the dividend and Q is the quotient. Quotient is the result or the answer of your division. Dividend is the one wherein it is the whole number where you are dividing, and the divisor is the one that divides your dividend. So your G of X or your D of X, this one is your divisor multiplied by q of x plus the remainder that is equal to your p of x or the polynomial itself. This is what we mean by division algorithm. It means that a polynomial is equal to the product of its divisor multiplied by the quotient multiplied by its quotient added by the remainder. So that's it. For property number 2, it is stated that polynomial p of x is divisible by a binomial x minus a if and only if p of a is equal to 0. So let's have an example of this. So if we have x squared plus 3x plus 4 divided by x minus 2, let's find the answer. Okay, it is divisible by a binomial x minus a if and only if p of a is equal to 0. So let's try to check if p of a is equal to 0. Okay, so at this point, if p of a, okay, so p of our a here must be x minus 2 equals 0, so x equals positive 2. Okay, so our a here is positive 2. So p of positive 2 is equal to 2 squared, this is your x squared, plus 3 times 2, that is your 3x, plus 4, that is equal to 4, plus 6 plus 4. So your p of 2 is equal to 14. Since it is not equal to 0, okay, then we can say that this polynomial is not divisible by x minus 2. And so if we try to put here x minus 1, for example, x squared plus 3x plus 4 divided by x minus 1, let's try to check if it is x plus 1 rather. Let's try to check if it is divisible by this binomial. So we have p of, so since we have x plus 1 here, therefore our a is equal to negative 1. So negative 1 squared plus 3 times negative 1 plus 4. Negative 1 squared is positive 1. 3 times negative 1 is negative 3. And plus 4. Okay. So what do we have here? Negative 1 times negative 1. We have positive 1 minus 3. We have negative 2 plus 4. The answer is positive 2. So since p of negative 1 is not equal to 0 and it is 2, therefore x squared plus 3x plus 4 is not divisible by x plus 1. So only if the answer here is 0, therefore we can say that this polynomial is divisible by the given another binomial. So let's continue. We also have this remainder theorem. If p of x is divided by x minus a with a remainder r, then p of a is equal to r. Take note that as what we have done here, our remainder will be this one. Example, if we divided x squared plus 3x plus 4 by x minus 2, and the answer here is 14, therefore we can say that the remainder is 14. And in this case, we can say that the remainder is 2. Okay, let's go back to the third property. It states that p of x is divided by x minus a with a remainder r, then p of a is equal to r. So the answer for that, for p of a, is our remainder. And also we have factor theorem. A polynomial p of x divided by q of x results in r of x with 0 remainders if and only if q of x is a factor of p of x. So when q of x is a factor of your p of x, then your remainder will equal to 0. Okay, so let's have here the example in division of polynomials. So we have here m squared plus 14m plus 31 divided by m plus 10. So let's arrange that. When using long division, we can have m squared plus 14m plus 31. Remember to arrange the polynomials with degrees or with exponents in decreasing order. And also, all you have to consider is the first term. So just divide the first term here. M squared divided by m, the answer is 1m. So we write m here in line with your m in the dividend. So then go back to multiplication. M times m, we get m squared. Then m times 10, the answer is 10m. Then same process with your irregular division is you have to divide them. You have to subtract them. M squared minus m squared, of course it's 0. Then 14 minus 10 is 4m. Then bring down your 31. So 4m divided by m, we get positive 4. Then 4 times 4m, we get 4m. And 4 times 10, we get 40. So if we are going to subtract them, Then this will become 0. And 31 minus 40, the answer is negative 9. So this will be the quotient in dividing the item number 1, and the remainder will be negative 9. We can also check this using the synthetic division. So in synthetic division, all we can do is to arrange the coefficients of the polynomial. So we have 1m squared, 14m, and 31. Then also, you have to divide it with c, or you have to identify your c here. So m minus c is equal to m plus 10. So if you are going to identify your c, then therefore your c is equal to negative 10. So all you have to write here is negative 10. Then use synthetic division. First step is to bring down your 1 and multiply it to negative 10. 1 times negative 10, the answer is negative 10. Then all you have to do is add. Okay, so add 14 and 10, then we get positive 4. Then 4, again, multiply it back to negative 10. 4 times negative 10 is negative 40. And then you also have to add them. 31 plus negative 40, it's negative 9. So this last number will be the remainder. And since we have x squared here, or sorry, m squared here, therefore our answer will be 1 degree lower because it is divided by m raised to 1. So that is m plus 4 with remainder negative 9. Let's continue with our number 2. Number 2 is p squared plus p minus 79 divided by 9. So using long division, let's arrange the polynomial according to degrees and divide it by p plus 9. Always remember that you only have to check on the first term. So p squared divided by p, we get p. P times p is equal to p squared. Then p times 9 is equal to 9p. Then all you have to do is subtract them. So p minus 9p, then we get negative 8p. Bring down your negative 79. Negative 8p divided by p, we get negative 8. Then 8 times p, we get negative 8p. And negative 8 times 9, we get negative 72. And so, if we are going to subtract them, we have to change the sign of our subtrahend and follow the addition rules on integers. So we get 0 here, and negative 79 plus 72 is negative 7. So our remainder will be negative 7. Let's check using the synthetic division. 1 for the second degree, 1 for the p raised to 1, and negative 79. And our c is equal to negative 9. Okay, negative 9. Bring down 1. 1 times negative 9. The answer is negative 8. Negative 9 rather. So 1 plus negative 9, we get negative 8. And negative 8 times negative 9, the answer is positive 72. So, negative 79 plus 72, the answer will be negative 7. So, our answer for synthetic division coincides with our answer on long division. The answer will be 1p minus 8. So, same thing with long division, that's p minus 8. Let's continue with the third example. Arranging them, we have k squared minus 4k plus 11. Take note that our examples are 10. So you can have a lot of examples while viewing my video. So k squared divided by k, we get k. Then k times k, we get k squared. And k times negative 3, we get negative 3k. Then subtract 4k minus negative 3k. That will become negative k plus 11. Negative k divided by k, the answer is negative 1. And negative 1 times k is negative k. Negative 1 times negative 3, the answer is positive 3. So if we have to subtract them, 11 minus 3, the answer is 8. This will be our remainder. Let's check it using synthetic division. We have 1, negative 4, 11, divided by, take note that our c here is positive 3. Okay, since we have k minus 3, so our c is positive 3. All you have to do is bring down 1 times 3, we get 3. 4 plus negative 3, we get negative 1. Negative 1 times 3, the answer is negative 3. And so 11 plus negative 3, the answer is 8. Therefore, our answer will be k minus 1, remainder 8. Question number 4, let's have here. X cubed plus 10x squared plus 13x plus 36 divided by x plus 9. Take note that we are going to consider only the first term. X cubed divided by x is x squared. X squared times x, we get x cubed. And x squared times 9, we get 9x. Okay, so 9x squared. Okay, 10 minus 9, we get x squared. Copy your 13x. X squared divided by x, we get x. X times x is x squared. And x times 9 is 9x. So 13 minus 9, we get 4x plus 36. 4x divided by x is 4. 4 divided by x is times x is 4x. And 4 times 9 is 36. Oh, can you see that if you are going to subtract them, the answer is 0. Therefore, on this case, our remainder is equal to 0. There is no remainder. Let's check it using synthetic division. 1 for x cubed, 10 for x squared, 13 for x, and 36 for the constant. And our c here is negative 9. Let's try to check if we'll have the same answer with the long division. Bring down your 1. 1 times negative 9, negative 9 here. 10 plus 9, we have positive 1. 1 times negative 9 is negative 9. Add them, we get 4. 4 times negative 9 is negative 36. And take note, 36 plus negative 36 is equal to 0. As you can see, there is no remainder. And the answer will be x squared plus x plus 4. It's the same as the answer for long division. I hope you can comment down below your questions or your impressions regarding our discussion. Okay, let's continue division of polynomials with this one. So again, m cubed plus m squared minus 36m plus 42 divided by m plus 7. So we get m squared, m cubed plus 7m squared. If you subtract them, we get negative 6m squared minus 36m. So negative 6m squared divided by m is negative 6m. Okay, so we have negative 6m squared. Negative 6m times 7, the answer is negative 42m. Okay, so if we subtract them, this will become positive and they will become 0. If we have positive here, we get 6m plus 42. So 6 divided by m is positive 6. We get 6m. 6 times 7 is 42. Okay, take note that we don't have remainder here. Let's try to check with our synthetic division. 1, 1, 36, 42. Then, our c is negative 7. First is bring down 1. 1 times negative 7 is negative 7. Then add them, we get negative 6. 6 times 7 is positive. Sorry. 6, negative 36 rather. 6 times negative 7 is 42. Then we get positive 6, and 6 times negative 7, we get negative 42. And so our remainder is 0. So this will be m squared minus 6m plus 6. It coincides with our answer with long division. Okay, let's proceed to number 6 example. 90r cubed plus 145r squared plus 77r plus 29 divided by 9r plus 10. So, just consider the first terms first. 9r cubed divided by 9r, we have 10r squared. 10r, go back by multiplication. 10r squared times 9, we get 90r cubed. And 10r squared times 10, we get 100r squared. So if we are going to subtract them, we get 45r squared. Then bring down your 77r. 45, again, divided by the first term, which is 9, we get 5r. 5r times 9 is 45r squared. Then 5r times 10, we get 50r. Okay, so subtract them, we get 27r. Sorry, it's 27r. And bring down your 29. So 27 divided by 9, we get 3. 3 times 9 is 27r, and 3 times 10 is 30. So if we are going to subtract them, the answer is negative 1. For sure, our remainder will be negative 1. So let's try to check it with synthetic division. 90, 145, 77, and 29. And our C here will become 10 over 9. That's negative 10 over 9. Okay? So first thing is bring down your 90. 90 multiplied by negative 10 over 9. So you can cancel this one, your 9. And this will become 10. 10 times negative 10, the answer is negative 100. If you add them, we get 45. So 45 multiplied by negative 10 over 9. If you cancel them, we get 5 here. So we have negative 50. Okay, negative 50 plus 77, we get 27. Then 27 times negative 10 over 9. If we cancel them, we have 3. That is negative, sorry, that is negative 30. Okay? So negative 30 plus 29, the answer is negative 1. So this will be our remainder. And, okay, 90, bring down your 90, and 45, and 27. Okay, take note that we have 9 here as our coefficient here. So, 90 divided by 9, that is 10. 45 divided by 9 is 5. And lastly, 27 divided by 9 is 3. Okay, so we get 10r squared plus 5r plus 3. Okay, since we have a divisor 9 here, we can have here 10. 90 divided 9 is 10 r squared plus 5r plus 3. This will be the final answer. Okay, remember that your answer for synthetic division must be divided by 9 first. So you can find your answer here. Okay, so if you don't put over 9 here and you don't divide 9 to our answer in synthetic division, you will never arrive to your correct answer. Okay, so always remember that if you have a divisor here, you really have to divide your answers. Let's continue with number 7. So we have 2x to the fourth plus 5x cubed plus 5x squared plus 10x plus 8 divided by x plus 2. So 2x to the fourth divided by x is 2x cubed. So again, go back by multiplying. We have 2x to the fourth plus 2 times 2, we get 4x cubed. If we subtract them, we get x cubed plus 5x squared. Then x cubed divided by x, that is x squared. X squared times x, we get x cubed. And x squared times 2, we get 2x squared. If we subtract them, the answer is 3x squared. Bring down 10x. 3x squared divided by x, the answer is 3x. 3x times x, we get 3x squared. And 3x times 2, we get 6x. So subtract them. The answer is 4x, then plus 8. 4x divided by x, we get 4. And 4 times x is 4x. And 4 times 2 is 8. Take note that our remainder here is equal to 0. Okay, we have 0 here. And for synthetic division, we have 2, 5, 5, 10, 8 divided by negative 2. That will be our C. So bring down 2. 2 times negative 2, we get negative 4. 5 plus negative 4 is 1. 1 times negative 2 is negative 2. 5 times 2 is, 5 plus 2 is 3. 3 times negative 2 is negative 6. Then we get 4. 4 times negative 2 is negative 8. Then our remainder is 0. Let's try to check the coefficients. 2, 1, 3, 4. Okay, that's correct. So 2x cubed plus x squared plus 3x plus 4. Example number 8. As you can see, our example number 8 here have degrees which are not in order. So we have fourth, but we don't have x cubed. We only have x squared, but we don't have that variable x. Okay, so first thing in doing long division is you have to arrange them. Okay, 1x to the fourth plus, since we don't have x cubed, that will be 0x cubed plus 4x squared plus 0x minus 45. This is only to fill the gap on the dividend. And all you have to do is copy your divisor, x squared plus 9. Then divide using the concept that we have used. Just prefer first the first term. So x to the fourth divided by x squared, we get x squared. X squared times x squared is x to the fourth. And x squared times 9, we get 9x squared. Okay. So if we are going to subtract them, we get 4x squared minus 9, we have negative 5x squared. Negative 5x squared divided by x squared is negative 5. Negative 5 times x squared is negative 5x squared. And negative 5 times positive 9 is negative 45. If you bring down negative 45 here, then our remainder is 0. So take note that this is very important when you are dividing polynomials, because if you don't put 0 there, you will never find the correct answer. Okay, so our correct answer is x squared minus 5. Let's try to check with synthetic division. Again, we have to arrange 1 to the fourth power, 0 to the cube, 4 for the squared, 0 for the x, and negative 45 for the constant. Then, what will happen to our answer here? Okay, sorry. We cannot use synthetic division here because it is squared. And sometimes all we have to do, there is another solution for synthetic division, but then we will not discuss it right now because this one is squared. Okay, so let's continue with our number 9. We'll have long division. Okay, so 2x to the fifth plus x to the fourth minus 15x cubed minus 2x squared plus 10x minus 24. Okay, divided by x squared minus x minus 4. So, 2x to the fifth divided by x squared, we get 2x cubed. Then we have 2x to the fifth. 2x cubed times negative x is negative 2x to the fourth. And 2 times negative 4, we get negative 8x cubed. So if we are going to subtract them, we can have 3x to the fourth minus 7x cubed. Then continue dividing. We get 3x squared. So 3x to the fourth minus 3x cubed. Bring down your negative 2x squared. And 3x squared times negative 4 is negative 12x squared. So subtracting them, we get negative 4x cubed plus 10x squared plus 10x. Okay, continuing, we get negative 4x. So negative 4x cubed plus 4x squared plus 16x. Okay, subtracting them, we get 6x squared plus, sorry, that's minus 6x minus 24. So 6x squared divided by x squared, we get positive 6. 6 times x squared is 6x squared. I don't have any space here now. Negative 6x and 6 times it's negative 24. So our remainder is equal to 0. That will be the answer for number 9. And for number 10, we have here x squared plus 9x minus 7. So you really have to arrange it according to decreasing exponents. So divide it, we get x squared minus 3x, and subtracting them, we get 12x minus 7. Okay, 12x times x, I divided by x, we get 12. 12 times x is 12x, and 12 times negative 3 is negative 36. Okay, so 7 minus negative 36, the answer is positive 29. So our remainder here is 29. If you are going to check it, we have 1, 9, negative 7 by 3. Okay, so bring down 1, 3, 12. 12 times 3 is 36. And 36 minus 7, we get 29. So this will be the remainder. So I hope that you have learned a lot from the discussion. And I hope that I can discuss to you later on dividing polynomials with quadratics using synthetic division. But at this point, I will not discuss it right now, but next time. Okay, thank you for watching. I hope that you have learned a lot from this activity or from this discussion. Any questions or suggestions for those people who are watching? So if there are no questions or suggestions, I may end this live stream right now. Thank you for those people who have watched me. God bless you.